My name is Bouskill, and I am, in fact, a card-carrying anthropologist, and I do work in Meta's infrastructure. Specifically, I work on our reliability engineering team. And kind of out there in the world, a little less so at work, but like especially in this town, I get a lot of interesting reactions when I tell people that I'm an anthropologist. One that I get all the time is like, cool, what's your favorite dinosaur? I'm not a paleontologist, but if I were, the answer would obviously be a pterodactyl, Patimothy. I totally stole that joke. I stole that joke. This is from the great Will Santino. He was kind enough to let me show it today. Give him a follow. He's very funny. Another one I got that was kind of a head scratcher was like, ew, bugs? I'm like, bugs? I'm like trying to think about it. I'm like, oh, I think you mean arthropods. I'll give it to you. Arthropods, anthropology, they do sound kind of similar. I love reliability engineering, so give me all of your software bugs, but if it's got an exoskeleton and like lots of extra legs, like no thank you, I'm all set, don't want it. Moving on, Indiana Jones, wow, cool. Like, all right, we're getting warmer, yes. Archaeologists are a type of anthropologist. They study the artifacts of human history. Also very closest when I get like, ooh, like the show Bones. I love that show. If anybody remembers that show. Yes, forensic anthropology is the study of human remains within the context of law enforcement. No, I regret to inform you, I am not studying human remains after a crime in Meta's infrastructure. Can you imagine how wild that talk would be though? Like, somebody call Casey, we found a femur next to the continuous integration desks. That talk would get this place would be full, I'm sure. Anyways, so obviously there are several different subfields of anthropology, and they range from the study of primates through to linguistics, and they all overlap to give us a scientific understanding of who we are as humans. So you might have been able to guess, I work with modern day humans, and I analyze this incredibly powerful tool called culture that humans have always used to adapt and survive. And I've worked all around the world, but I'm really, really lucky to say that my current field site is Meta's infrastructure. And although I guess I'm kind of trained as an academic, I kind of aspired to be like you. I want to fix things. I want to engineer things. So what am I doing in Meta's infrastructure? Trying to re-engineer our culture. I'm trying to show how paying attention to our engineers as people helps improve tools, policies, our infrastructure's operations. So today I'm going to tell you a little bit about what we've been doing to mature some of our internal processes with respect to our reliability program. And we'll talk about why doing prevention and risk mitigation is hard, and culture change to adapt to these challenging times is hard. But we can study it systematically, and we can use that to drive the right culture changes. And you don't need someone who is an expert in dinosaurs or arthropods to do it. I also just want to acknowledge that there are actually lots of anthropologists who work in tech. Oftentimes their function is as user experience researchers, and they're doing some really terrific work, oftentimes interfacing with end users and identifying design solutions for products. I really love doing UX when I can, but what I'm going to talk about today is a little bit different, or rather, I see a tool in a much broader toolkit of how we can understand how to affect change with research, and mostly understand how people operate within our engineering systems. So we can employ qualitative and quantitative data collection methods together. It's mixed methods. We can take from the policy analysis playbook I often do. We can design interventions, do future forecasting and risk analyses, and use experimental designs where we can actually test out our hypotheses. And we can use all of that understanding of the human side of engineering processes to help shape our responses, right? Those practices, policies, and tools that we're developing. And doing that to adapt to this like ever-evolving complexity that seems to be happening faster and faster. So as I mentioned, I'm going to talk about this through the lens of reliability. And obviously reliability is a really important part of DevOps, but I think that you'll find that a lot of these lessons apply to other aspects of DevOps more broadly. And ultimately, at the end of the day, I really just believe that paying attention to how engineers feel about their work processes, how we design the system to work for them, makes their work lives easier, makes the company better. That's kind of important, right? Because your jobs were already hard, but they've gotten arguably more complicated in the last few years. We've got pretty intense global competition, capacity constraints, layoffs, burnout, and like, oh yeah, this whole AI arms race thing that we found ourselves in. So we might operate in a world of zeros and ones, but we are human after all, and we're juggling a lot of demands. So paying attention to culture really helps us build a better environment where we can better cope with and deliver on all of those different demands. So in today's talk, I'm going to present 3 different case studies of different reliability interventions, each with their different impetus, so a different starting point, a different purpose. When I say intervention, I mean any strategy employed to improve a situation, right? So it's kind of in contrast to like one single solution. In each of these cases, culture, or maybe more importantly, cultural misalignment, re-examining these kinds of assumptions that we held about what would work, actually helped us to see where we needed to adjust our approach and arrive at a better outcome. It all starts from this premise that we've got to reduce the activation energy that it takes to let people do the right thing, especially when we get swamped by other competing demands. The first case I'm going to talk about is a homegrown, grassroots cultural change that we drove to ensure that engineers are given enough credit for doing reliability work. The second one was a heavier top-down approach to addressing risks made from configuration changes, where we needed to bolster up our tooling and education on the ground to get us to a more sustainable approach. The third was deals with an AI-based intervention that had worked at Meta, but outside of our infrastructure. And it really needed to be better tailored to the particular cultural context among our engineers that work lower in the stack. It's a good reminder that you can't just add AI and stir. It's not a panacea, it's not a cure-all, it's not ready for prime time everywhere. So in all 3 cases, we're going to see how directives really only work if they jive with the experiences, the constraints, the circumstances of the people that are working at work. Now, I really don't think that you all need to be convinced that culture and people matter. I mean, obviously, you're here, which is great. To demystify how we actually study culture, how we study people, and how we can use it to make better interventions, primarily to address risks. Called a cycle of crisis and complacency. Might sound familiar. We know that there's a big threat out there. We sort of ignore it. We deal with it when it becomes a big problem, and then we proclaim, like, never again will we go through this. And then time passes and the whole cycle repeats itself. I've always been really interested in why humans are notoriously bad assessors of risk. Why are we not good at doing things proactively? That reminds me, I never told you about my training as an anthropologist, what type of anthropologist I am. I'm trained as a biocultural anthropologist, so that's a blend of biological anthropology, like human evolution, or how did humans become human, and cultural anthropology, that is documenting and comparing present-day cultures. That might sound kind of heady, but in my defense, I listen to you all talk about Kubernetes all day, so just stick with me a little bit. You might be wondering, though, at this point, how human evolution could possibly be relevant to Meta's infrastructure. Hell, at this point, you might be wondering why there's a Neanderthal with a righteous mullet up on the screen. I promise I did not give Meta's Gen AI any hairstyle prompts for this one. And in my professional estimation as a bioculture anthropologist, I don't believe that Homo neanderthalensis was rocking the business in the front, party in the back. We don't think that he was an ice hockey player, but there's really no way to know for sure. It remains one of those great debates at anthropology conferences. But the reason why human evolution matters is because we got a lot of prehistoric machinery going on up here, and it wasn't really built for the world that we live in or the places that we work. We didn't work back then when our brains became human, right? So my mentors have called this mismatch Stone Agers in the fast lane. You got a Stone Age brain, we're living in a very fast-paced world. There's a mismatch. And part of this mismatch is that without some prompting, humans aren't great at assessing risk. We rely on heuristics that fit our mental models about how things should be or how we want them to be, even when it's not really in our best interest. We tend to focus on the tangible things that are right in front of us. And worse is when the underlying system, like cultural values or the resources that are available to us, kind of prioritize us doing the things that give us the clearest return. So our neurological infrastructure and our greater society are not really built to make us notice and fix slow burn abstract problems that, for the most part, you can kind of like leave for another day, right? We do instant gratification in a lot of ways. And we tend to take complex systems for granted when they're working well. I worked in public health. I still work in public health, studied epidemiology, and I spent most of 2019 going around the world trying to get policymakers to care about pandemic preparedness. You all know how that turned out. Fast forward to today. Has anybody been to the grocery store lately? Yeah? Anybody see the price of eggs? Could you find eggs? I mean, obviously there are plenty and plenty of public health practitioners who forever have been, warning against the risks and the dangers of bird flu, but we sort of have taken it for granted that the system would just take care of it. And hey, I live in Los Angeles. I'm in a high fire zone. We knew that wildfires were a real threat, but massive spending on wildfire resilience just simply was not at the top of our priority list until the halls of this very convention center were lined with evacuees. So we don't necessarily have a system with rewards for proactively addressing risk. But it's also really hard to have a key performance indicator around the absence of a problem, right? KPIs. Anybody else living in this world? I love a good corporate buzzword, like narrator. That was a lie. When you live in a world of KPIs, it's generally, don't tell anybody. When you live in a world of KPIs, it's generally easier to make the case for I did X and I moved the needle Y%. What's our KPI though in this case? We didn't break anything? That sort of flies in the face of a KPI. I don't know, is anybody else really frustrated by the fact that it's sometimes really hard to do the common sense thing? Yeah, where's Jay? I was just talking with Jay about why documentation sucks. And it sucks because there's no clear KPI, but when you really need clear documentation, you need it. It's there, it's the common sense thing to do. Anyways, so my mantra, of course, has kind of become all right, if it's hard to get people to do the right thing, it's hard to prove the counterfactual with a KPI, how do we make it easier? How do we adjust the system? How do we remove unnecessary friction when it comes to preparing for threats that are serious but not yet urgent until they are, right? I argue that realigning our cultural values and equipping people with the right policies and tools can be a catalyst for making prevention matter. And we have learned this lesson with respect to reliability risk at Meta. And, we actually learned it quite a few times when we were still Facebook. Then other priorities came on the scene and we had to relearn again how important reliability is. So back in those early days, we were eating, sleeping, breathing the motto, move fast and break things. And we did break some things in the name of innovation and speed. And by my estimation, that it was probably the right thing to do in those early days, get to market, fix things later, right? Probably the right move. Besides, the things that broke back then weren't critically important. So in 2004, when I first got a Facebook account, that's right, people, I don't study dinosaurs. I am one. But back then, it might have felt like a crisis, but it wasn't a crisis if the site was down and I couldn't find out if that nice guy from calculus class was single, right? It was fun. It felt like a toy. Our angry uncles with a surprising penchant for geopolitics weren't on there yet. But fast forward, right? We had to make this fundamental transition to move fast with stable infra. By this point, in 2014, we had 1 billion monthly active users, right? I personally, I had gone from this fun toy to something that I depended on when I was out in the field doing research just to communicate with people, right? So we made this transition to move fast with stable infra. It sounds wholly uncool, unfun, but it was absolutely necessary. So to prevent the whole break things part of the equation, we put together a team of senior engineers, data scientists, technical program managers, and a cadre of production engineers. These are our boots on the ground that really enact reliability work. And so not too long after starting this reliability engineering team, this is really cool. The managers understood that we needed to do that kind of cultural realignment to make reliability a first-class value. So get this, they actually asked if there was an anthropologist who could help them systematically study, measure, and operationalize a change to our reliability culture. I felt really lucky to basically be in the right place at the right time. I still do. So as you all know, you can't change what you can't measure, live in that KPI life. So how do you measure culture? How do you get after something as abstract as reliability culture? Well, the first thing is the most universal tool in an anthropologist toolkit, interviews. It means you have to go out and talk to people. So, side note, I know that that's not everyone's favorite thing to do. We have a bunch of Facebook interest group within Meta, so imagine like Facebook inside Facebook. There's an extroverts at Meta interest group. It has 97 members. You can imagine how big our company is. It's got 97 members. Yep. Does anyone want to guess how many are in the introverts at Meta Group? This is real. This is real as of like Monday. 10,000, 5,000? $1, Bob. Anybody else? 4,103. Please don't change. You are wonderful exactly how you are. But it's, again, like I said, I know it's not everyone's favorite thing to do. But back to that sort of foundational research bit with these semi-structured interviews. Semi-structured interview is where a researcher comes in with a set of questions, but they leave room while asking the interviewee questions to talk about the things that matter most to them. What do they find most important or salient? In many cases, all I had to do was ask engineers, say, what comes to mind when you think about reliability at Meta? And we were off to the races. It's obviously impossible, though, to go and get everyone's perspective, so you have to be really deliberate about the sample of people you interview so that you're not overly biased in terms of what you hear and you understand for whom your findings are relevant. So for me, this involved a fair amount of networking to make sure that I was getting a representative sample to try to reduce that bias. That meant finding people across all levels of seniority and tenure, which is actually really interesting because I had to often infer it through proxies, since one aspect of our culture is that we don't disclose our seniority level to each other. But I also had to make sure that I was getting right areas of specialty, the teams that people are working on, geographic locations, individual contributors versus managers, et cetera. Also, if you want to reduce bias, it's really important not to have any sort of an explicit but also implicit hierarchy between the person who's asking the question and the person who's answering them, right? Like if the interviewer can impact the person who's being interviewed, if they can impact their career trajectory, like you're probably not going to get that person to be very forthcoming, right? That's not the kind of information you're going to get that's going to drive culture change. I mean, I know for myself, I would probably just give the answer that I thought somebody wanted to hear if they could control my career trajectory. I don't have that. I don't have that ability. So in many cases, engineers, I hope, feel as though they can just speak freely with me. And they do. They oftentimes do not hold back, which is great. Yeah, also, don't stop doing that. That's the best. And when you interview dozens of people, you're left with tons of interview notes, pages and pages, and your team depends on you to make sense of those insights that people share. So after conducting the interviews, I gathered input from the broader team to apply categorical metadata. In qualitative research, we refer to them as codes. These are descriptions of like how teams measure reliability of what they own, the perceived barriers and facilitators that they had in doing that work, the reasons that they had for a bad on-call shift, like what's making for a bad on-call experience, et cetera. So here's a screenshot of the qualitative data analysis software MaxQDA. It's just one of several similar programs that I'm happy to tell you about anytime. And it's just to give you a sense of what it looks like to apply that metadata to domains of interest and get to it right in the interview transcripts. And this helps determine the most salient constructs. What really matters? What are the things that people care about in the words that they use to describe them? I'm just going to present a few of those common themes that we learned a few years back when we were doing these interviews. So back then, people would talk about why reliability was becoming a necessity. And they would also talk about how they were starting to really feel the weight of reliability risks the greater we scale. But they struggled with a lot of competing priorities and demands. They also still do. They didn't want to break things necessarily, but they also didn't want to lose our competitive edge. A software engineer summed it up. She said, "I love reliability and I'm frustrated by doing it. It's not as recognized, it's difficult, it requires a lot of work, and the tooling is really bad." That whole like not holding back thing. You can turn those themes into survey questions. The reason why you would do a widespread survey is so that you can quickly get insights from a lot more people than we can interview. So an interview is going to kind of give you that depth, whereas a survey is going to give you the breadth of the data. Also, in a move-fast world, we like to have a good pithy quote, but we also want numbers. We want quantitative data, KPIs. Surveys help generate that data. They also allow for comparisons in time, like are we trending better or worse on the perceived value of reliability work? Are the interventions that we're working, are they actually resonating with engineers? Do engineers feel like they're working? So we've been tracking reliability sentiment in a survey of our infrastructure engineers for a few years now, and we've completed 5 waves of survey data collection. Another point, though, to add here is that you're all very busy. You might have experienced what's called survey fatigue. This is where you're like really sick of, especially like bad survey questions. You're like, I don't know how to answer this. Like, it's really important to keep things short, test out the questions in advance with people to make sure they make sense, and also show people what you're doing with their data. If people give you their time, give them something in return, all right? Show them what you're learning. I'm going to show you just a few of the early survey findings. So back then, 78% of respondents said that their teams value reliability work, but most agree that we still should be doing more of it, and about half noted that it was really hard to identify which reliability gaps to address. People also noted far and away that competing priorities, dependencies, and complexity of our underlying system, and difficulty measuring reliability were top barriers. And when it came to what would help facilitate doing more reliability work, is that people just get recognized. They get incentivized to do this work. And they wanted that to be on par with, say, shipping a new feature. All right, so like first things first, you're not going to get people to do this hard work of reliability if they don't believe that they're going to be rewarded for it. So enter in our first intervention. This one was grassroots, and armed with the good qualitative and quantitative data that we had collected, we went to leadership. We went up all the way to the top to make a case for including reliability as a core expectation of all engineers. Of course, it also took a lot of support from influential senior engineers to really back that change too, but it worked. And we made an institutional systems change, and it was a really considerable leap forward for changing reliability culture. But in the workplace, as you all probably know, what lives on paper doesn't automatically live in practice, right? It takes a little time for top-down changes to trickle through the ranks, for people to really believe that they were going to be recognized for doing reliability work after a long time of kind of seeing that there's more credit for shipping new features. So in the meantime, we ramped up a program started by our colleagues in our network organization called the Reliability Standard Bearers, where respected engineers in each infrastructure organization sit in on annual performance reviews to ensure that reliability impact is weighted and rewarded against other kinds of contributions. The reliability standard bears don't really look like that. Obviously, we don't wear ties in the office. Sorry. That bear looks like he has 3 cubs, a mortgage, and he can't wait for Casual Friday. Gen AI miracles. But really, the cool thing is there's now over 100 volunteers who track every mention of reliability in every IC's review. And then they sit in on these performance reviews and they interject just to make sure that managers are really giving reliability impact a fair shake. So watching these really healthy discussions and deliberations, seeing people kind of grapple with their own preconceived notions about what counts as impact, and then making changes, it's a really cool sight to behold. And it really shows that collective power of our grassroots culture to drive that sort of change and also to serve as a guardrail, right? Like power to the people on the ground, right? The goal, of course, is to nudge managers to do this recognition themselves and solidify that on-paper change to match the experiences of our engineers. So in essence, we do want to put these reliability standard bearers out of a job. And we are well on our way. So this year, 86% of performance reviews described reliability impact, and in several cases that led to a higher performance rating. But I'm still getting engineers come to me and tell me that they just don't think they're getting enough credit for doing reliability work. So I had thought we had better put some stats behind that belief. Like, how pervasive is this? So after we made the change, again, that systems-wide change to make reliability a core expectation, I'll throw out that we have been asking people whether they feel that reliability work is recognized. And most answered yes. But we hadn't been asking how satisfied they are with the degree to which reliability is recognized. In other words, most said reliability is recognized in their performance reviews, but did they think it was recognized enough? So on this latest survey that we ran a few months ago, we asked just that, and we found that satisfaction with how reliability is recognized was unfortunately only 55%. So we're going to have to keep these bears in business a little while longer, especially as we hold ourselves to a high reliability bar while continuing to push the envelope on our big bets. It takes a lot of hard work to keep these things on the rails, and that work deserves to be recognized and rewarded. That bear is crying. I actually don't even know if that's physiologically possible, but again, thanks Gen AI for the sad bear. And again, like I said, I really like how in this case it's a grassroots movement that is driving it. All right. Getting people to do the right thing is not always as grassroots or as fun as bear avatars, but remember when I said that we had learned that lesson of crisis and complacency more than once? Yeah, we learned it again several times with regard to configuration changes. We had a couple of site outages from bad configuration changes that made it into the press. You might remember that. Last year there were a few across the industry. These were triggered by changes that went to production without sufficient validation and deployed everywhere all at once. I don't have to tell you that the work to integrate ubiquitous mechanisms like gradual rollouts and robust high-quality health checks is tough. It's hard work, right? It takes dedicated time on a roadmap to actually set this up and maintain what we at Meta call change safety protections. So reducing risk when making code and configuration changes. Leadership agreed and kind of was making a push for this top-down directive to get everyone to slow down a little bit and address some of these known vulnerabilities throughout our system. But we also wanted to be sure that a big initiative with really significant asks, asking people to slow down, to drop other work and take this on, wanted to make sure that would resonate with our engineers. Turns out we actually had survey data to show that only around half of our infra engineers felt confident in their team's change safety mechanisms. I wanted to find out more, so I did interviews to understand how teams think about making and monitoring configuration changes. Like, what were the tools they were using? Who had the expertise to do this? Like, what were the trade-offs that they were making? And as we learned, expertise on how to actually do this work was fairly specialized and limited within teams. And part of this related back to suboptimal experiences that people had with our existing tooling. So at that point, I teamed up with a user experience researcher who's now revamping the tools that we use with regard to configuration change safety, specifically around our canary mechanisms and health check quality. But that whole thing about there's only a few people on each team that know how to do this, I also worked with a team of engineering experts in the space to produce professional change safety 101 videos to help spread knowledge across a team. This effort led to some really incredible strides throughout the year, not just the videos, but the whole thing taken together, both top-down and also empowering people with knowledge and tools. We were able to reach some really ambitious targets and reduce pretty significant revenue loss that we had been going through. And I'm really looking forward to rerunning the survey this year, and I'm really hoping that we see a pretty significant jump in that figure of 52% of people having confidence in our change safety processes. I really hope that improves. So just to recap, this policy was something that people weren't naturally going to gravitate towards. They weren't, without that kind of extrinsic motivation, they weren't going to be incentivized to go and work on it. But we had enough data to show that we couldn't just make that top-down directive and leave it at that. We had to empower people with the right knowledge, skills, and easier-to-use tools to be successful. But we also know to be really judicious when we're asking people to take on this kind of big top-down initiative. So try to lay down the hammer only when it's absolutely necessary. The last case study was interesting. It deals with our AI-based intervention that was developed outside of our core infrastructure. So inside the company, but kind of coming in from outside of our very protective bubble of our infrastructure. And the intention of this intervention was to detect the risk that a code change could break something in production before it goes to prod. It's a pretty good concept, right? It's a win for developer efficiency if it works and for reliability. And it's innovative, of course, to be automating core aspects of developer workflows, but it was missing some really important cultural context among our infrastructure engineers who themselves tend to skew a little bit more senior and have oftentimes worked in their respective spaces for a long time. Like, they know their code, right? Adding automation into our workflows on risk assessment, again, it's a pretty good goal, but only when the people creating it and the people who are receiving it agree that there is a problem to be solved, and they agree that whatever the AI is doing is going to solve that problem. And nearly everybody across industries, I do a lot in healthcare and in public health, they would say the same. They're sort of realizing that you can't just add AI without a solid understanding of the existing workflows and whether people feel like the addition of an AI would benefit, whether they'll trust it. So as I mentioned, like, another team had sort of pitched this idea to flag proposed code changes as risky and notify engineers that they should consider sending their code change off for additional code review. Just a notification, not a hard block on actually shipping that code. One thing that we prize in our culture is autonomy. And we kind of sensed, like, from what we knew about our infrastructure engineers, that their reactions might range from skeptical to cautiously optimistic about automating risk detection. So we thought, all right, we'll let them pilot this out with a handful of teams for a limited amount of time. And while we're tracking whether or not there's a quantitative reduction in risk, I'm going to collect some qualitative data on how it's impacting developer workflows. So I just observed engineers interacting with the model. And as I did, they would call out that the model didn't explain why or what parts of the proposed code were contributing to the risk. In other words, they couldn't necessarily reason about the risks themselves and troubleshoot. And of course, probably like you all, they want to be hands-on problem solvers themselves. So without clarity over what data the model was trained on and without explainability over what exactly was making their code risky, many were quick to either get frustrated or throw out the recommendation entirely. They really didn't like it, and they didn't shy away from expressing it. Also, another really important point is, like, the lower in the stack you work, the greater number of dependencies and therefore risk to making the changes, right? So there's already sort of inherent risk to working in this space. And engineers know this, and in several cases, they already had their own workarounds to reduce risk. So in their eyes, the intervention was not addressing the right problems. And at the end of the month, we did not observe a convincing enough reduction in risk. And in conjunction with the qualitative data that highlighted the sort of friction between the intervention and our infrastructure culture, we influenced our colleagues and leadership to hit pause on the intervention until we can better align the model with the real needs of our engineers. I think in a broader sense, though, this case study showed us that we should not assume that an intervention that works in one context is going to work across the board. There are very few out-of-the-box solutions and sometimes make more friction than reduce it. So I really urge all of us who are invested in leveraging AI in our workflows to systematically study the experience of its use so that we know how to optimize it, especially when it comes to risk and how people think about risk. We should absolutely not shy away from it, but be mindful of how we do it. And don't just release it out into the wild and forget about it. Pay attention, track outcomes, and make sure that the benefits justify the costs. We've done a handful of other interesting interventions that have been, in part, informed by the cultural data that we've collected. Here are just a few of the initiatives. I'm really, really happy to talk about this anytime. We regularly run disaster recovery drills. We've developed a solid SLO-based measurement program, right? So it kind of helps a little bit with that KPI problem. And we launched tooling and guidance on how to build a 0-to-1 reliability program through a reliability program maturity model. So as I mentioned, I'm always really glad to talk about this, and I would love to get your perspectives and understand what you're doing in your respective jobs. And I'm also really encouraged to say that on our latest survey, 91% of the respondents now say that their teams value reliability. That's up from 78% when we started surveying. And we've managed to do it, I'd say, while keeping our competitive edge in the throes of a pandemic and layoffs and you name it. And we've transformed this hyperscale infrastructure into a planetary scale infrastructure that powers products now serving nearly half of humanity. One of our engineering directors, CQ Tang, recently wrote about this in the proceedings for the Association for Computing Machinery, ACM, and check this out. This is kind of cool. One of the first things that he mentions is our move fast culture. So it's about our infrastructure, but first thing is about our culture. So I guess in a sense, like, we still got it, right? The other aspects of our culture that CQ calls out include things like our monorepo, the fact that we do research and production, and we have a common infrastructure for all of our products that enables standardization and optimization. These kinds of like stated corporate values are incredibly important for understanding the principles of how we design and execute on our work, but they don't necessarily describe what it feels like to be a part of our culture. I mean, if somebody asked me like, what's Meta's culture like? I wouldn't be like, well, we have a monorepo. I mean, I would. Like, eventually we'd get there, we'd talk about it, but it might not be the first thing, right? So we have kind of like these very explicit structures, formal rules and procedures. Every company does, right? But then we have a bunch of informal norms, rituals, symbols that give us that shared sense of camaraderie and purpose. All that stuff's not going to appear in an ACM report, right? But we do a lot to support each other so that we can move fast and keep adjusting to this increasingly complex infrastructure. In our work culture, yours too, we want to feel incentivized and reassured that our contributions are valuable. We want a sense of purpose. We want to do that while we're preserving our agency. We want to be successful without burning out. We want to prevent future problems, and we need the right policies, practices, and tools to be able to do it, because inevitably, unknown problems are going to arise, right? So we kind of want to be able to draw on that organic culture of support. So for us, we create happy hour rituals. We have shared workspaces where we can ask for feedback and get help on the fly. We make absolutely ridiculous t-shirts, and we shitpost, like, a lot, and it's great. But we also know, like, when that complicated outage occurs, we know that we can trust the person next to us to help us mitigate it. So we want to feel that bond when we're in the trenches. And then we want to have a way to decompress when we're out of the woods, right? You want to be able to laugh with people, with your fellow incident responders in that case. It's the stuff that we kind of take for granted that actually really makes up the fabric of our work matters. So please keep doing it in whatever flavor makes the most sense in your own culture. I am really excited about what's next for our industry and how I can hopefully keep connecting the dots between all these human-centric factors. People are going to make or break even the best ideas. And the best ideas are not going to work without the right policies, practices, and tools. So in this fast-paced world where everything feels monumental, how do we make it easy for people to do the necessary, sometimes mundane, unflashy work that's required to be able to ship those monumental tech advancements and do it safely? Just a few notes to close. I will say I am indebted to my engineering colleagues who really patiently and skillfully break down engineering complex engineering topics, and they teach me. I love coming to engineering conferences because I learn so much, but that really comes from the kindness and the generosity that I think is really pervasive throughout this community. So I really, really love it. You never know when just taking that extra time to sit down with one of your non-engineering colleagues is going to set their career on a new course that they never thought would happen, but they love it, right? Also, as I understand it, and from what I've seen, operations teams generally want to keep things stable. And it's really kind of the developers that really want to like innovate and change. So there's kind of this like really fun inherent tension to doing DevOps. But of course, we all have to be working together to be looking around corners for that next threat while we're burning down that ever-long list of priorities that seems to be arriving faster and faster with each passing year. So as we engage with today's talks and with each other, let's consider how qualitative and quantitative data that we all can collect to reflect our cultures can go a long way at least scoping and forging the right discussions. And while I'm always really keen to collaborate, please keep in mind that this work is not limited to social scientists, right? So you can all take elements of this. And you don't have to reinvent the wheel, and you certainly don't have to be at a planetary scale infrastructure to be able to take this on. I've given similar talks at SRECon and at Scale, and I've had people reach out afterwards saying, like, you know, I really need some help getting leadership convince leadership that boosting our reliability program matters. And so I would say, like, okay, why don't you start with talking with people that are getting woken up at 3 in the morning, right? Who's on call? Who's consistently having to get up? Who's sleeping with that cell phone on their chest, like, trying to fix these issues? What do they think is wrong? Did they know that all this stuff was a problem before they got woken up for the 10th time? Like, what has been preventing them from actually going and taking that on themselves? Take those insights, turn them into a short survey, under 5 minutes, right? Get a regular pulse on the sentiment. Then co-design interventions to instill that kind of culture and behavioral changes, get data on those interventions, iterate, make it better, and repeat. It's how we keep advancing while keeping people fulfilled and supported. I'm really looking forward to today. I'm really looking forward to talking with you all. Thank you so much. Please don't hesitate to get in touch. Thanks.